Discrete random variable probability distribution can be developed using empirical method that we saw in the previous videos, and it can also be developed using some theoretical defined distributions. And one such, we're going to be looking at two different discrete probability distributions that are defined distributions. One is binomial distribution, the second one is Poisson distribution. And also there are such defined distributions for continuous random variables as well. And we'll come to that in just in a little bit. Now first, binomial distribution. For an experiment, okay, for in a statistical sense, for an experiment to be a binomial distribution, these conditions must be true, and this is also referred to as Bernoulli process, and that is each trial of the experiment should result in only one of two possible outcomes. So an experiment has only two possible outcomes, something like tossing a coin and you get either head or tail, or you make a sales call and you either make the sales or you don't make the sales. So you apply for mortgage and you either get approved or you don't get approved. So that kind of stuff. Then the probability of the outcome of each outcome must stay the same from trial after trial. So the first time when you toss the coin, if it is 50-50 for head or tail, the second time you toss the coin, it's the same coin, so the probability stays the same. The third time you toss, the probability stays the same. So with the probability staying the same from one trial to the next is a requirement, and that the 2 and 3 are the same thing. If the probabilities are same trial after trial, and then the trials are said to be statistically independent. So the third requirement, okay, I'm going to count 2 and 3 as the same thing. The third requirement, which is listed here as 4, is you must have a fixed number of trials. Okay, so for this process to be a binomial distribution process, you need to know how many times you're going to try. Okay, 5 times or 10 times or 15 times. It has to be a positive integer. So if these three requirements are satisfied, then we have a formula that we can use to compute probability, and that formula is called binomial formula. Let's head over to Excel. Okay, so here are the three requirements of Bernoulli process. Each trial results in two possible outcomes. They are generically called success and failure. The probabilities of the two outcomes stay the same trial after trial. That is our statistically independent trials. And the number of trials is a fixed number. So now we're going to define some notations. Okay, we'll use the notation n to stand for the number of trials, the fixed number of trials. And we'll use the notation lowercase p to stand for the probability of success. Okay, here success should be in quotation marks. We are using kind of a generic term as what we are looking at. So sometimes, like if you're looking for fraud, or success here would be identifying the fraud. So something, this success is kind of a placeholder for the outcome that we are interested in. And then Q is going to have to be 1 minus p, because there are only two possible outcomes. So these two probabilities have to, because the sample space has only two outcomes. If one probability is p, the other has to be equal to a number such that the sum of the two will be equal to 1, and therefore Q has to be 1 minus p. So this is our Bernoulli process or binomial distribution. So in that case, what is the random variable? Okay. Random variable here is defined as the number of successes in n trials. Okay. If you're going to do 5 trials, what is the probability that there will be 3 successes? Something like that. So in that case, the sample space is going to be, okay, if you have n trials, the sample space is going to be 1, 2, well, the sample space is going to be, what is the smallest possible value for x? The number of successes in n trials. 0. You don't have, you may have no success at all. So starting from 0, then the next possible value is 1, then the next possible value is 2, all the way up to n. So that is our sample space. Now we need to have a probability for each value of x, then we will have a probability distribution. And that probability formula is given by this. So probability that x is equal to r, whatever r may be, then you have, this is our combination formula, n factorial divided by r factorial times n minus r factorial. So that's combination formula times the success p to the power r, okay, the number of successes that we want, times q to the power of n minus r. So these, the power, when you add up, it should be equal to n. So that's our formula.